Um, I am Carol Polanskey, and I'm the project scientist for the Psyche mission. Our PI, Lindy Elkins-Tanton, could not be here today, but she spoke to this group a year ago, last January, and gave the initial overview of the Psyche mission to this organization. And so I'm here today with a follow-up. I'll do a little bit of a summary just to get everybody up to speed on where we are, and then talk about what's happened in the last year. So I first wanted to start with just a discussion of our science objectives for the mission. And the first one, which is our key science objective, is to determine whether Psyche is a core or if it's unmelted material. And so I want to make it very clear that the mission from the beginning has never counted on Psyche being a core. Rather, we are a mission of discovery to answer the long debated questions about Psyche's origin. And so we can be very successful as long as we can determine what, how Psyche came to be. Our second objective is just to look at the relative ages of different regions of Psyche's surface. We don't expect to be able to do any type of absolute age dating at all, but just to be able to understand the sequence of formation of areas of the surface. And then we're going to look at the global abundances in the parts of the surface that appear to be in the metal phase of the light elements, sulfur, potassium, and silicon. And then I guess this particular objective here does sort of presuppose that Psyche is a core, and if it is, then to see whether or not it formed under more oxidizing or more reducing conditions than Earth's core. And then finally, simply our sort of most open-ended objective is to just characterize Psyche's topography. This is a body that no one has visited before with the spacecraft, and so we sort of expect to be surprised by what we find when we get there. So it's first to start talking a little bit about the overview of our mission. We do have a electropropulsion spacecraft, and we have a fairly straightforward trajectory to get to Psyche. We launch in August of 2022, and we've got a lovely sort of almost direct to Mars type trajectory that with a gravity assist of Mars in May of 2023. We plan to do a full characterization of the instruments, calibration, taking Mars observations, and a rehearsal for getting to Psyche. And then we arrive at Psyche in January of 2026. And then we have a science operations phase that looks very similar on purpose to what you may have seen in the past for Dawn science operations. At the very beginning of the proposal process, Psyche wanted to adopt the Dawn operations concept as sort of a heritage component of our mission. While we don't have the same spacecraft as Dawn had, nor do we have the same instruments, we actually have the same mission profile. And having that defined early on and having it be fairly mature enabled us to very quickly then hone in on the requirements for the spacecraft and the instruments and the rest of the system. And so it's a different type of reusable mission from an operations perspective. We have 4 different science orbits that start at high altitude to allow us to characterize Psyche as we go, in particular to characterize the gravity field so that our navigators can do a good job of getting us placed into each subsequent orbit. And each one of our orbit phases is expected to return results towards our level 1 requirements in a different area. So in our first orbit, our highest altitude orbit, is when we expect to be able to meet our requirements for magnetic field detection, if there is one. And then in orbit B is our primary orbit for the imaging campaign, where we'll do both topography mapping and imaging with our 7 color filters on our imager. Orbit C is for our gravity science objectives, although I should mention that in every one of these orbits, we take data with all of our instruments. We don't have any power problems or anything to preclude us doing a fully integrated science campaign at each orbit altitude. And then last, at our lowest orbit, this is when we finally get close enough for the gamma ray instrument to make measurements of composition. So this is a little bit more detail about our instrument suite. We have two multispectral imagers that are redundant because they share a role as being optical navigation cameras. And they are being led by Jim Bell at ASU and built by Malin. And they have heritage from mass cameras and are very similar to what's being built in 2020. And so these are fairly standard cameras that have a lot of heritage behind them with Malin.
Built at UCLA, where they have, and above this, they have something like
40 years of experience building magnetometers for space applications, and being led by Ben Weiss at MIT, who's working with Chris Russell at UCLA. And this particular setup, this relationship has worked out very well for us. It's been a really great partnership between these two organizations. There will be two magnetometer sensors, and they're going to be on a 2-meter boom so that we can do radiometry to remove the fields from the spacecraft. And these magnetometers have specific heritage from MMS and InSight. And then finally, we have our gamma ray and neutron spectrometer. This is the gamma ray instrument has its heritage from Messenger with a high purity germanium detector. And then the neutron component has its heritage from Lunar Prospector with helium-3 sensors. And the team lead for this is David Lawrence at APL. And again, we very specifically sought out high heritage instrumentation that we felt had very low risk for the mission. In addition to the 3 science instruments in the payload, we also have a gravity science experiment using our X-band antenna. This is an overview of our flight system. The spacecraft, what we call the SEP chassis, the solar propulsion component of the spacecraft, most of the big boxy part in the picture is built by Space Systems Loral, SSL, now it's called. And they have an extremely long product line of EP spacecraft in Earth orbit. This will be their first deep space mission, but we have worked very hard with them to make sure that we are disciplined in not asking them to change anything from their standard product line. Probably the only new requirement we put on them is the magnetic cleanliness program for our magnetometer. And so you can see in this figure here where we have the instruments placed, we have the 2 imagers coming. They told me I can't use the pointer here, so I'll just have to talk to the picture. You can see where the multispectral imagers are poking out of the side of the spacecraft, and that will be our mostly meter orientation when we get to Psyche. The magnetometer sensors are on 1 2-meter boom, and then there's a second 2-meter boom that has the gamma ray and the neutron spectrometer, so that we're trying to get the GRS far away from the magnetometer, trying to get as much of the instrumentation as far away from the magnetometer as possible. Yes.
Can use the mouse to point. The mouse.
Oh, the mouse. I don't even know where that is. Okay. Oh, okay. Oh, this is a PC. I don't. Let's not touch it. We have a very large solar array for a deep space mission, but this is fairly typical for what SSL produces, and so it's actually not even the largest in their product line. And there's one other component of the payload, which is the Deep Space Optical Communications, which is a technology demo that we are flying. Managed by a completely different project within NASA, and we're just providing accommodations for it to do most of its operations within the first year after launch, between launch and getting to Mars, essentially. One thing I forgot, and I will go back for a second to mention, is that there's been one change since the CSR in our payload, and that is with the Neutron spectrometer. We recently added a third helium-3 tube with the specific intent of being able to disentangle hydrogen out of the measurements we make at Psyche. At the time of the proposal, hydrogen wasn't a real topic of concern, but now that there have been detections on Psyche, we wanted to add something to enhance our ability to deal with hydrogen. So now to talk a little bit about the asteroid, 16 Psyche. I think you've all heard an awful lot about Psyche, so I'll just really briefly mention that it has a high radar albedo that's been measured multiple times, most recent measurements from Shepard, and a high thermal inertia. And these have led folks to speculate that Psyche is the core of a larger planetesimal that was disrupted through multiple hit-and-run collisions back in the early days of the solar system. There have been a variety of measurements of Psyche's density that have been made. We heard two of them, or one of them this morning in the first talk of the day. And so there are density measurements ranging from about 4,000 kilograms per meter cubed from these recent observations up to almost 7,000 kilograms per meter cubed, and from earlier observations. And so there is a quite a range here, but what we think that we are doing with this mission is providing a very strong testable hypothesis. Is Psyche the core of a differentiated body or not? And so this next slide is something that Lindy had drawn on her whiteboard a while ago when we were looking at a trade, or basically trying to assess the robustness of our instruments to meeting our requirements in the STM. And so it turned out to be kind of a useful tool to walk through the thought process of how we're going to use the instruments that we're carrying and the measurements that we're taking to answer these questions about Psyche's origin. So at the top is some options for Psyche's magnetic field. It could have a beautiful bipolar field, which nobody really expects to see, or more likely, if it was a disrupted core, it would have sort of a complicated field that's the result of a jumbling of magnetic domains from a disruptive event that would then have come back together in sort of a randomly oriented set of domains. Or there could be no field at all. So if we detect a field, then we essentially have answered the question as to whether or not Psyche was a core, because that's the only way we can imagine that we would be able to see a magnetic field at Psyche. However, if we don't see a field, that doesn't mean that it's not a core, because it's possible if Psyche had solidified from the inside out rather than the outside in, that there wouldn't be any remnant magnetization left from an early dynamo. So then we look at the scale of the mixing of the silicates and the metal that we see when we get there. So if the silicates and the metal are intimately mixed together, sort of below the resolution of the imager so that we can't detect specific silicate domain or regions of silicates versus metal, then we can say that that Psyche has not differentiated and that we have intimate mixing of metals and silicates. Whereas if we have large provenances of silicates on the surface, then they could be from pieces of the mantle that that fell back and reaccreted after the disruptive event. This doesn't, we still have to look further at what those silicates are composed of, but this is sort of the first level of discrimination here with respect to the silicate and metal ratios. We are going to be looking at the correlation between gravity and composition. However, I should point out that gravity alone is not a diagnostic measurement for us. It's going to help us interpret the other measurements that we make, but on its own, it's not going to answer this question. So then we look at the composition of any large regions of silicates that we may find. So they could it could either be achondrites, in which case then it's probably the mantle of the body that again reaccreted after a disrupting event. However, if it's chondritic in origin, then it could either be So it could be a later impactor and therefore really not diagnostic. If Psyche is a core, then there's a possibility that there would be evidence of volcanism on the surface, sulfur and potassium volcanism, and we would be able to look at that both with our GRS instrument as well as with filters on the imager. In particular, we have some filters that are specifically designed to be able to identify troilite and iron sulfite on the surface. And then finally, we have one of our really good indicators, which is the nickel content. And so this is derived using the gamma ray instrument. For most meteorites, or for most iron meteorites, the nickel is about between 4 and 12 weight %. And so if we measure less than 4 weight % of nickel, then we can assume that Psyche is not a core. But if it's in the 4 to 12 or even greater than 12 weight %, then that's another good indication that Psyche is a core. So we will go through the mission and compile all of the information that we make along the way, and then eventually we should be able to answer, or at least further make progress on answering this question of Psyche's origin. So looking at where we are in the project overall development timeline, we are a few months away from PDR in early March. We had our PMSR a while back and passed that. And then we go into our phase CD in sort of mid-2019 through, and with our launch in the end of, or August of 2022. And then we have our cruise phase from 2022 until very early of 2026. So right now, with PDR being a few months away, we're pretty much focused on PDR preparations. We've had a number of subsystem PDRs already. All 3 of the science instruments have completed their PDRs, and 6 other of the spacecraft subsystems. We've got 6 more subsystems coming up for their PDRs in the next couple of weeks. We have a whole pile of gate products that have to be produced, and those are all on track. We completed our phase CD budget exercise before the beginning of the year, and so we're really getting ready for PDR, and we feel well prepared to go into this. So far, I mean, part of the what's helped us along the way is the fact that there have been very few changes from the CSR. It's really been a fairly smooth development with no major additions or changes of scope. So we did fund 2 science risk reduction tasks during phase B to get deeper understanding of certain measurements that we're going to be taking when we get to Psyche. And those are both wrapping up now before the PDR. The first one was to gain some more insight into impacts into metal targets. And so Simone Marchi led a group of folks. We did some experiments up at Ames with the vertical gun facility, and a paper has now been submitted just in the last few weeks, wrapping up the work in that area. And so we're looking forward to the review process on that. And secondly, there's been little work done in modeling what magnetosphere would look like, or magnetic field would look like on an asteroid. And so at MIT, Rona Aran, working with Ben Weiss, have been doing a lot of very detailed modeling of what we might expect to see at Psyche under a wide range of conditions, going from the worst case assumptions of the smallest possible magnetization of the material and the smallest possible magnetic domains, through to the extreme of if it's very highly magnetized, and looking at whether or not that, a highly magnetized Psyche with a magnetosphere, whether that would propose any threat to the spacecraft from trapped particles. So that work is wrapping up, and a paper is in preparation to be submitted soon. And also we've got 6 abstracts from the Psyche team coming up at the upcoming LPSC. And finally, I'll just talk a little bit about our student collaboration and our outreach. We had our first year of student capstone projects was focused at ASU with ASU students. And this year that has been opened up to students from other universities. And right now we've got 29 teams of students working on 17 different projects. So it's been a really very successful program. The ASU folks have also teamed up with the True Story Films and created a video about the Psyche mission, and it recently won a Rocky Mountain Emmy Award for Best Director, so we're very excited about that, and we've got 3 more films in the can on the way. There's also an initiative called Psyche Inspired, and this program is more bringing in artists and musicians and folks from all sorts of disciplines to create wonderful things. A tremendous amount of artwork has been generated from this process, and now it's in its second year. And also we have a blog where we've got at least 20 stories now on the blog, and these range from just the day in the life of what it's like to write science requirements or working on electrical propulsion, or some of the more engineering aspects of the project, as well as some of the science questions. And so we've been really trying to keep the public engaged in this mission through the long process of getting it developed and launched. And with that, I'm happy to take any questions.
Questions? Please repeat the questions.
Paul Abel, Johnson. So question, you're going to be doing an encounter with Mars. I was wondering, are you thinking about anything to do with the Phobos and Deimos, and is that sort of similar in terms of the body observations of those bodies, and compare that with what you expect a Psyche in order to calibrate? And then also during your cruise phase after that, are you going to look for any possible flyby encounters of another asteroid small body?
All right, so the question was first whether or not we were going to do any observations of Phobos and Deimos when we're doing the Mars flyby, and then whether or not there's any other targets of opportunity along the way. So the planning for the Mars flyby is not gone into any great levels of detail at this point. Our main focus is the gravity assist that we need for navigation, and making sure that we meet planetary protection rules and things of that nature. If Phobos and Deimos are visible with decent lighting conditions, I can imagine we would certainly take that opportunity to look at them. I can't tell you right now whether or not the geometry is going to work out for that right now. We just haven't gone into that level of detail. At the moment, I'm not aware of any other target of opportunity along the way. We are not planning to divert to go anywhere specific to catch anything else. And to my knowledge, at this point in time, there's nothing that's opportunistic that's shown up. But it would be nice if it did.
Sorry, I have an online question from Martin Elvis. Any chance of a second encounter with Psyche?
Post-Psyche.
Post-Psyche. Okay, so we that would be an extended mission, which in the proposal, what we suggested is that we get even closer to Psyche than we are in our orbit D. But that's a long ways away. These spacecraft are very capable, but right now, as far as an extended mission is concerned, we're looking at getting closer.
And these images are spectacular. Are they purely notional, or do they reflect the phase B study?
So the images were a collaboration between a Hollywood movie artist and Lindy, our PI. And so the idea was that she talked with him a lot about what would be realistic if, in fact, Psyche was a metal world. What kind of, morphology would you expect to see? So, I mean, obviously they're spectacular from an artistic, he's a sci-fi movie guy. But they are, to some extent, you know, constrained by what's scientifically possible.
Other question? More? One more.
Hi, Kelly Miller, Southwest Research. I saw that you're expecting to get sulfur, potassium, and phosphorus abundances. Do you have reasonable hopes of measuring any other elemental compositions?
Yeah, we have a list of different elements that we are trying to measure, aluminum, calcium. I don't have them all memorized right now, but there's a number of things that we'll be able to measure in addition to those.
All right. Thank you very much, Carol.